Hey guys, welcome back. Pre-Calc Lesson 12.1b, second half of our first lesson. We're going to talk about rational functions. So first of all, what are rational functions? Rational functions are simply functions that are fractions. So it kind of looks like this. F of x equals p of x over q of x. All right, that would be a rational function. So a lot of times these have asymptotes, vertical or horizontal or both. So what determines whether something is a vertical asymptote? I know we've talked about this a lot in the past, but let's kind of dive into it a little bit deeper here. So I'm just going to pick some random value on my x-axis, call that -2, and say, well, hey, that's a vertical asymptote. So what does that mean? That means some function approaches that and then either goes up forever or goes down forever. So what we like to say for a vertical asymptote is as x approaches a number, so in this case, -2, y approaches positive or negative infinity. So again, in this particular example, we would say as x approaches -2, y approaches infinity. Okay, horizontal asymptote. All right, so let's make a little sketch here for horizontal asymptote. Again, let's pick a number. I'll pick 2. And there's a horizontal asymptote. So what happens is our function would kind of do this. So now how would you describe that situation? So now what we're going to say is as x approaches positive or negative infinity, y approaches a number. So in this case, what we'd say is as x approaches positive infinity, y is going to approach 2. And that's kind of how a horizontal asymptote works. Okay? All right, so how are we going to find these horizontal and vertical asymptote tests? Well, the first one's pretty easy. Vertical asymptote, what we're going to do is we're going to set the denominator equal to 0, then solve. Okay, so that'll give us our vertical asymptotes. Again, this will change slightly as we get into limits and we start talking about some discontinuity, but for now, we're going to set the denominator equal to 0, solve. That'll give us our vertical asymptotes. Horizontal is a little bit more challenging. All right, so stay with me here. Given f of x equals p of x over q of x. So basically, p of x is the numerator of our rational function, q of x is the denominator. If the degree of p of x is greater than the degree of q of x, there is no horizontal asymptote, none. Okay, so what would a function like that look like? Well, we'd have something like f of x equals x squared plus 5 over x. So we're talking about the degree of the numerator and the degree of the denominator. So what this is saying is if the degree of the numerator is more than the degree of the denominator, no horizontal asymptote. Okay? Well, let's flip that. What if the degree of p of x, the numerator, is less than the degree of q of x? What's going to happen there? Well, now we're going to say the horizontal asymptote is y equals 0, which, as you guys know, is the x-axis. Okay, so what would an example look like there? Oh, I don't know. Let's see. X squared minus 4x plus 2, let's say, over x cubed minus 7. So again, we're comparing the degree of the numerator, which in this case is 2, with the degree in the denominator, which in this case is 3. So this degree is greater than the degree of the numerator. So now I have a horizontal asymptote at y equals 0, which is the x-axis. All right, I'm sure you guys can figure out what the last scenario is. What if the degree of p of x, which is the numerator, equals the degree of q of x, the denominator? Then the horizontal asymptote is the ratio of the leading coefficients. All right, well, that seems a little bit more complicated. Let's take a look at an example. So let's make up an example here. I don't know, 2x squared plus 4x minus 5 over 4x squared minus 7. So now again, as you compare these, what you notice is that the degree of the numerator and the denominator, both 2, they're the same. So how do I get my horizontal asymptote? Well, my horizontal asymptote is going to be y equals the ratio of the leading coefficients. So that's going to be 2 over 4, or 1/2. So my horizontal asymptote in this case is going to be y equals 1/2, and I found that by taking the ratio of those leading coefficients. All right, let's try a few examples. All right, so now I want to find any asymptotes for the following functions. All right, so f of x equals x over x squared minus 4. I like to start with vertical asymptotes. I think they're the easiest, so let's just do that. Vertical asymptotes. Okay, so what I'm going to do first is I'm going to set the denominator equal to 0 and solve. Well, I'm a big fan of factoring in this situation because it helps you remember there's 2 possibilities, plus or minus 2. All right, so my vertical asymptotes will be x equals plus or minus 2. You can write it out separately. You can write it like that. I don't care. That's fine. All right, so what about the horizontal asymptotes? Well, what we have to do for this is we have to remember that we're finding the degrees of the numerator and denominator and comparing them. So what we said is if the degree of the denominator is bigger, then our horizontal asymptote is y equals 0. Okay, so we have to kind of go back, and this is the hard part because there's 3 scenarios to this. The degree of the top is bigger, then there's no horizontal asymptote. Degree of the bottom is bigger, it's y equals 0. If the degrees are the same, it's the ratio of the leading coefficients. Okay, so it's going to be a little bit harder to keep track of. Okay, let's look at the second one here. Now, there's a little bit of an issue with this one because if you go back to the definition of a rational function, you'll notice it's a single fraction. This is not a single fraction, so we've got to do a little bit of algebra here. My common denominator in this case is going to be an x, so basically what I need to do is I need to take this and express it as a fraction with x in the denominator. Well, quite simply, it's just going to be x over x. Okay, so now if I put this together, I have x plus 2 over x. So this is the function I'm going to now find my asymptotes for. So again, the first one I like to do, I always start with vertical asymptote because it's easy. Denominator equal to 0, x equals 0, and we're done with our vertical asymptote. So now, horizontal asymptotes. Well, I need to take a look at the degree. That's 1, that's 1. The degrees are the same. If the degrees are the same, your horizontal asymptote is the ratio of the leading coefficients. So not a lot of work to do in this case, but it's going to be y equals 1 over 1, which obviously simplifies to just y equals 1. Okay, now let's talk about finding roots and y-intercepts. So if you remember, we did this earlier in the year, but to find the roots of a rational function, you're going to set the numerator equal to 0 and solve. So by doing that, you're going to get the roots. Obviously, the roots are where the graph's going to cross the x-axis. Now, the y-intercepts, it's actually very simple, but we have a tendency to kind of forget this one. Think about a y-intercept. Let's make a quick sketch here. So let's say the graph does something like this. Okay, and here's my y-intercept. Well, what are the coordinates of that? It's 0, comma something, some number. How do you get that number? Well, you simply set x equal to 0 and evaluate. So basically you just set all the x's in the function equal to 0, whatever number you have left, well, that's just your y-intercept. Could be 0, could be any number. Okay, so let's put that into practice here. Find the roots, the y-intercept, any asymptotes for the following functions. All right, so our first one here, we have f of x equals x plus 1 over x squared minus 4. Now again, order doesn't really matter. If I have to find the roots, the y-intercept, vertical asymptote, horizontal asymptote, I just kind of go in that order. I just find it easier. So I'm going to start with roots. And remember, roots will be numerator equal to 0. Okay, so x plus 1 equals 0, x equals negative 1. That's going to be a root. My y-intercept. So for my y-intercept, I set x equal to 0. Well, look at what I'm going to have. F of x equals 0 plus 1 over 0 squared minus 4 equals negative 1/4. So there's my y-intercept, negative 1/4. Okay, so some of the new stuff. So now what I want to talk about, vertical asymptotes. If you remember, for vertical asymptotes, that's setting the denominator equal to 0. So looking up here, I've got x squared minus 4. Again, I'm a big fan of using difference of squares in this situation. It just reminds you that you have two possibilities here. So for vertical asymptotes, it's going to be x equals plus or minus 2. And lastly, the challenging one, horizontal asymptote. Okay, so if you remember for this one, what we have to do is we have to take a look at the the degree of the numerator and denominator. So in this case, the degree of the denominator is larger. So what that tells me for my horizontal asymptote is that's going to be y equals 0. Okay. All right, one more. F of x equals x minus 2 over x squared minus 9. I'm going to kind of go in that same order. I like to do roots first. And again, you don't have to write this out. I'm just doing it for the sake of the example. But if you remember, roots are going to be numerator equal to 0. So x minus 2 equals 0. X equals 2 is a root. Your y-intercept, that's going to be setting x equal to 0 in this expression. So y equals 0 minus 2 over 0 squared minus 9. That's going to be 2/9. So your y-intercept is 2/9. Vertical asymptote. We're going to take our denominator, set that equal to 0. Okay, so again, x plus 3, x minus 3 equals 0. So for my vertical asymptotes, I'm going to have x equals, and again, you need to include the x because these are lines, remember, the equation of a line, plus or minus 3. And the last one's going to be our horizontal asymptote. And again, we have to talk about the degree of the numerator, degree of the denominator. Numerator is 1, denominator is 2. The degree of the denominator is larger. So once again, I'm going to have y equals 0 for that horizontal asymptote. Okay? So as usual, please reach out if you have any questions. You can now do the homework associated with this lesson. Thank you.